Hello, BYW students, it's Mr. Sullivan. Today we're going to be doing a review of all sequences. Today's learning target is I can apply my knowledge of sequences by answering a series of questions. So today you're going to be looking at different sequences, and it's up to you to write the explicit formula to find the nth term of the sequence. So if we remember, we have arithmetic sequences and geometric sequences. So arithmetic is written in this form: a sub n equals a sub 1 plus d times n minus 1. Geometric are written in this form: a sub n equals a sub 1 times r to the n minus 1. In both cases, a sub 1 is your first term, d is your common difference, r is your common ratio, and n is just sort of like an x. It's what we're plugging in each time. Okay? So let's look at our first example. Before we go any further, geometric sequences are exponential in nature. And then arithmetic sequences are linear in nature. So they're going up by the same value each time by addition or subtraction, while geometric are multiplying to their next value. So let's look at our first example. Given the sequence 2, 8, 32, 128, the first question says, is the sequence arithmetic or geometric? So if we look, when I go from a 2 to an 8, I add 6. When I go from 8 to 32, I add 24. And then when I go from 32 to 128, I add 96. So I have a question for you. Is that arithmetic? No, it's not, because I'm not going up by the same value each time. So I know it's not arithmetic, so it has to be geometric. So now I have to figure out what I'm multiplying by each time. So if I look, when I go from 2 to 8, I multiply by a 4. 8 to 32, I multiply by a 4. From 32 to 128, I also multiply by a 4. So I can say this sequence is geometric because my common ratio is 4. And that would be your final answer. You're just multiplying by the same value each time, or dividing by the same value each time. So if I wanted to write a formula to use to find the nth term, I know I have to use this formula over here. My a sub n equals a sub 1 times r to the n minus 1. So that's what we're going to type first. So I have a question for you. If I look at the sequence, what's my a sub 1? Very good, it's my 2. So I have 2 times my common ratio raised to the n minus 1. And now I have a question for you. What's my common ratio? Very good, it's 4. So this is my explicit rule that I would use to find the nth term of this sequence. Now, if I want to use this formula to find the 8th term, everywhere I see an n, I plug in an 8. So what we're going to do is we're going to write down a sub n equals 2 times 4 to the n minus 1. Now, everywhere we see an n, we're going to put an 8, or substitute an 8. And now we're going to type this into Desmos. When I type this into Desmos, we need to make sure that we're putting a parenthesis around our 8 minus 1. Or if you want, you can just type it like this. I'm actually going to use my graphing calculator. So when I use my graphing calculator, I'm going to type in 2 times 4 to the 8 minus 1. Well, 8 minus 1 is just 7. Tell me what you get. Very good. I get 32,768. So I can say the 8th term of this sequence is 32,768. And that's my final answer. Now let's look at the following problem. Given the sequence 7, 12, 17, 22, answer the following question. Is the sequence arithmetic or geometric? And then explain. Very good. This sequence is arithmetic. The reason why is because I'm going up by 5 every single time. So this sequence is arithmetic because my common difference is 5. If you want to, you can also just say that it's going up by 5 each time. Now, part B says, write an explicit formula that can be used to find the nth term. So what we're going to do is we're simply just going to use our formula from above. A sub n equals a sub 1 plus d times n minus 1. So when looking at the sequence, what's my first term? Very good, it's a 7. What's my common difference? Very good, it's a 5. And then I have my times n minus 1. Now, whenever I have a number on the outside of my parentheses, I need to distribute. So I distribute my 5 to my n and my minus 1. So I get a sub n equals 7 plus 5n minus 5, because 5 times n is 5n, 5 times a minus 1 is a minus 5. Now I combine my like terms, which are a 7 and a minus 5. What's 7 minus 5? Very good, it's a 2. So I get a sub n equals 5n plus 2. Now that is my explicit formula that can be used to find the nth term. Part C says, use the formula to find the 8th term of this sequence. So all I'm going to do is everywhere I see an n, substitute an 8. So I have a sub n equals 5n plus 2. So now I plug in my 8. 5 times 8 is 40. 40 plus 2 is 42. And that's your final answer. So that's it for today. If you have any questions, please email myself or Ms. Townsend. Have a great day, ladies and gentlemen.